see you because we don't have school on Monday. Oh, go away.
Oh, Lisa, sad.
Go away. Go away.
I love you.
Okay. So we're going to work one really good giant example, and then your own, well, not really, you can work with the group, but you have your own assignment to do. Okay. Let's see. I left. Some people didn't grab it, and that's fine. I'll hand it to you now. Did you get a handout for the empirical? No one did. Okay. It's just a useful. I meant to pass this out yesterday.
You want a strawberry in this coffee?
Yeah.
You're sure?
A useful little handout about the 68, 95, 91.7, so you could reference it if you wanted to. You're welcome.
More stuff. All right.
I could give her a strawberry and we go get it
That was me this time.
Okay.
It's recording.
Yeah.
Can you edit it before you post it or something?
My videos?
Yeah.
I don't take the time to do that. I just
The first 2 minutes.
what I'm just going to do is say, hey, table 1 add a point, hey, table 3 add a point, thanks for not being on nerves. Okay, thanks.
Okay, cool.
Okay, thanks. You need to have out your notes and your formula sheet because we need to reference that Z table again. Okay. We talked yesterday about that 68, 95, 99.7, and it is amazing if they're actually asking you about 1 standard deviation, 2 standard deviations, or 3 standard deviations away from the mean. But odds are they're not, so instead you need to use what?
Z-score.
Z-score. So today we're going to practice using the Z-score. So it asks standard normal curve, which is talking about the curve we're looking for when we're looking at Z-scores. And as I mentioned yesterday, I think we even drew it on our notes, my God, do you not eat in any other class period? Lord Jesus, help me not to lose it today.
Sorry.
Woo.
Minus 1 point.
Jewish, you can't stick it up.
Okay, so
Don't worry.
the normal standard distribution we discussed yesterday, it has a mean of 0 and a standard deviation of 1, and every number, I think I forgot to say these words, every number on the x-axis is technically a z-score. So for instance, if we were to add a point on this graph, let's say 0.73, that would be a z-score. The z-score is 0.73.
Okay. You've probably answered this.
Maybe.
What defines what is a Z-score? Like a Z-score?
It's when we're making well, you have to have the words approximately normal or something about symmetrical or standardized. And then basically, if they're not asking you about the 1, 2, 3 standard deviations away, we're going to turn it into a z-score, which all we do is we standardize it by using that formula for a z-score was x minus the mean divided by the standard deviation. And that's when we're normalizing it. Technically, when we make a z-score, we've normalized the data. Yes, dear.
Do you mind if I simplify it a little bit?
Yes, please.
You know how yesterday 80 was 2/3 Z-score?
Yeah.
That means the 2/3 of the Z-score away from me. So there are another Z-score, or the standard deviation of 3. Since it's 2 away from 28, it's 2/3 of 1 Z-score away. For every like decimal we'll find, that's the percentage of 1 Z-score away that it is from the mean. Does that make sense?
I think that's what Jackson just heard.
That wasn't simplified.
That's
but
not simpler than that.
That's-
Standardizing with the variables or whatever you said.
that was
Do you
pretty-
liked it better without numbers, didn't you?
That
You liked it better with
either.
numbers? Did you like it better with numbers or without numbers?
I'm not trying to hurt your feelings today.
You can hurt my feelings. You liked it better with numbers. Okay.
I like this better. I like yours better.
Okay. Well, it doesn't matter. We're going to practice it anyway, so you're going to have it down. Basically, if it's not the normal 1, 2, 3 standard deviations away from the mean, we're going to have to use a z-score. Okay. So it says find the proportion of observations from the standardized normal distribution that are less than 0.54. Okay, less than. So let's draw us every single problem I see. I tend to draw me an ugly bell curve. That one was super ugly.
Your bell curves are nice.
And then 0, thank you for lying, 0.54. If I'm wanting less than, which way would I shade in life?
Yeah.
Less. So I'm going to shade this way. Again, the shading matters, and a lot of people, if they're going to mess up something involving Z-scores on their exam, it's because they're not paying attention. And they give you the other region that you wanted. They give this side rather than the purple side. Okay, and again, since they told me it was the standard normal distribution, I understand that my mean is 0 and that my standard deviation is 1. That's just understood. Okay, so all I'm going to have to do on this one is actually going to be super easy. I've got to go to my Z table. I've got to find 0.54. I need to erase what I did yesterday. 0.54. And I see the number 0.7054. So that is my answer. So the proportion of observations that were less than 0.54 were 0.7054. That purple region that we shaded is basically about 71%. Okay, are there any questions about that one? Yes, dear.
How do you find that this number on this table?
Okay, so 0.54, I went to 0.5, and then it's 0.54, so I had to go over to 0.54, the 4 column, and where they aligned is the number I'm looking for. Okay. And again, we know we're right because look at our picture on our table. Hey, that kind of looks like the picture on our paper. We don't have to do the 1 minus stuff we were doing yesterday right now. Jackson, you had something to say. Say it.
It was irrelevant, so I stopped myself.
Okay, perfect. Okay, so number 2 says find the proportion of observations from the standard normal distribution. Again, they told us standard normal distribution, so we know that the mean is 0. We know that the standard deviation is 1 because of those words. And then we want to know which ones are greater than negative 1.12. Greater than, you shade to the right. So now we've got to go look at our table. However, the table you and I were using has only positive values, yes?
Yeah.
So we need to flip over and look at the other table
The negative Z-scores.
with the negative
Not the same
Z-scores.
thing?
They're going to have some of the same values, yeah. The difference is going to be the shading.
So that O thing is always 1, right? Is that
That's the standard deviation, yes.
so that's the same.
Yes. Okay. So, negative 1.2. And then some of my negative signs are missing because life doesn't always copy well. Negative 1.12. Negative 1.12. 1335.
1314. Maybe, I think.
Yeah, 1.12 would be 1.1314, which is correct. So, again, what's weird with your thing that didn't copy well is that it didn't shade at the top well. So that is a correct answer, which is 0.1314. But someone just asked a good question. Really wasn't paying attention to who it was, to be honest. I was in my brain about math. We didn't actually have to solve it this way. We didn't actually have to use the other table.
So I asked if it was the same thing.
Yeah, so if we had used the table we've been using,
The absolute value of it.
yeah, so we went to 0.112, and we saw, I get that the ours was positive and this is negative, but you and I understand that the negative words, English phrases.
Yes.
Jeez Louise.
What?
Exactly.
Batman,
Do you remember how 1 standard deviation away, it doesn't matter if you're 1 positive standard deviation away or 1 negative standard deviation away, really you're the same area away?
Yeah.
That's one way to phrase it. Well, negative 1.12 is really the same area as positive 1.12. So if we look at the positive 1.12, it was 0.8686, yes. You're on this table, the positive one. And it was 1.12, 0.8686. Everyone see the 0.8686?
Yes.
But again, that would be if our region was shaded to the left. Is our region shaded to the left?
No.
Ours is shaded to the right. So we could have done 1 minus 0.8686, and we would have gotten the same answer. So Jackson can solve that problem 2 different ways. He can use the negative values, or he can do 1 minus the positive value one. But he's got to draw a sample picture first, or else he's going to end up getting his answer wrong. Okay, say words.
How do you calculate a z-score?
That we take.
X minus X bar?
Yes, yes,
Okay.
yes.
But that sheet just makes it so we don't have to do that.
If it says the word standard normal distribution, then they've already normalized. They've already turned it into z-scores for you.
So that's what that graph is?
Yes.
Okay.
Yes. We didn't have to do the work and make it a z-score. Yesterday we had to do the work and make it a z-score.
Got it.
Paragraph that again.
Yes,
Almost
again.
certainly.
Yes, absolutely. But they're gonna tell you the x, they're gonna tell you the x bar, they're gonna tell you the standard deviation. They're gonna tell you all the things. You just gotta plug and chug. That's what we're going to. That's what the coloring page is for. If we can get to it.
I love that.
Okay, you're good, baby doll. Okay, number 7. We're gonna do the same thing. We're gonna draw us a picture. We've got us a standard normal curve. We're gonna assume it has the same directions as above. To be honest, it should have said more, but it didn't. So we want to know greater than or equal to 2.12. So we can look at our table. 2.12 is 0.9783, but that was if our region was shaded to the left. Is our region shaded to the left?
No.
No, our region's shaded to the right. So we can't use that 0.9783. We have to do 1 minus that. Okay, so I've got a new 1 minus 0.9783, and I end up getting, I think, 0.0174?
It's 0.983.
983, thank bless you. Can't transpose and read at the same time. 983, 0, okay. But it should be 0.0174. But again, let's say Louise is feeling froggy.
Always special this week.
Let's just say he's feeling froggy, and he understands 2.12 standard deviations away from the mean. Maybe he could look at the negative one. Negative 2.12 already was 0.170, so it'd be a little bit of a rounding error possibly, but they'll probably get over that little tiny, tiny bit. Yes, dear?
Okay. I can't get my mind off this point system.
Okay.
Are we going to get punished if we don't achieve 5 points a day?
What tends to happen is if I get really busy and I do math all day, I'm probably just going to take whatever they need to get to the 5 and add it because they're doing what they're supposed to. We agree. They just don't talk that much.
Yes.
And then, so it's like if they need to add 4 and 4 leaves you short of 5, then you're in trouble.
It's just like,
But if they need to add 4 and 4 gets you to over 5, then good for you.
my problem is you so rarely deal them out.
Oh, yes, I
The
do.
first day that you're so generous, you get a point. You get a point.
Oh, you want some points? Let's get some points.
But
We can do
I'm
that.
scared
Number
to
4.
ask for points.
It's a 30% grade. Lord Jesus. Just do statistics, baby doll, and I swear you'll pass. I promise. 100% promise. Okay. Were there any questions about number 3 as to how we got the 0.0174? So you can do 1 minus what you actually got from your table. Or you can look at the negative version on the table, and it's going to be very similar, but with a rounding error, I believe.
Wait,
Unless
so
my brain
basically,
is
if
crazy.
you just want to use the same chart for everything, for the negative ones, you just subtract 1 from what the value is? You
Yes.
subtract it from 1?
Yes. So I tend to just use the positive and either just it is what it is or 1 minus the number. Yes. So either, but Sally simplified it, and God bless her for doing so. I tend to just use the one chart, and either I'm using my number or I'm using 1 minus my number. Yes, you can have a point for that. Okay, number 4, I need an answer because some people want some points. So can you give me an answer for number 4? We're wanting to know greater than 3.89.
It's on the chart.
Yes, I would.
Oh, okay. What are we going to do?
It's 0%.
So 2.
Okay, so if we use the surety property,
The
we
what?
can,
If we look at the top of the chart, 3.4 was already so many zeros. We assume it's so many zeros, it's ridiculous.
So 0.
We assume so, but what else could we use to help us figure this out?
A calculator.
Yeah, let's
We
use
can
it.
use Google.
Good, but that's not as fun.
I think it's fun.
So where do you find the z-scores? Someone find the z-scores and get your
Wait, you
group of
didn't
points.
tell us how to do
Press
calculate.
this.
I know it.
Oh, okay. I'm more with it today.
Are you?
I am.
I ran.
Because you can't use anything with a list, because this is all normalized.
Yes, ma'am. How many do you need?
So,
Points. Okay, this calculator's all messed up.
I'm not expecting points for being a good person, Sally.
Oh, this is so expensive.
That's gonna reward me in the kingdom of heaven.
Oh, Lord Jesus. Get over it.
Fancy them to do it.
you could,
Nobody owns a calculator. You realize is that we have a test, and that all my other children use these calculators. For the love, buy your own calculator.
Go rent one.
Rent one for $10. All my bad words want to come out today. I'm going to hold them in. I'm very disappointed in you right now.
Which one specifically?
All of the ones that don't own calculators. Very
I
disappointed.
own one. I just put triple A's in it.
wait, Miss Thompson, if the, what's it called, 3.89 is like the value, you subtract that from 0, which is the mean, and divided by 1, which is the standard deviation, you get 3.89.
3.89 is the z-score
So then
already.
what do you do?
It's already been standardized. Somehow we got to press buttons on our calculator and get it to talk to us about z-scores.
Wait, do you know
Variable
how to do it?
stats.
Okay, give me
One
a
variable stats is not going to work. One variable stats required a list full of data. We don't have any list full of data. We don't have any data to give it. We just need it to tell us things.
Someone
I
else
know.
wrote
Figure it
buttons
out
with a
for
Z on it.
points. Duh.
You use something?
I found it.
No, you don't.
You don't know that you did. There are lots of things that say Z under tests.
Pretty sure.
No, I don't button to press.
Press online.
Z test?
I don't know.
Wait, but you don't know?
Yes, I do, but I'm not telling you. The whole point was to get points.
Oh. I think it is Z test. Maybe.
Not gonna
Z-toast.
lie. How
Test.
Z.
I was like, what's Z-toast?
You aren't saying animal real fast, you know.
What?
What?
Oh, yeah, don't do that.
I get it.
I have a question.
I might have an answer.
What buttons do you press to find the Z-score?
It's definitely in the test.
I hit test and I get
I don't know if it's a Z test, one prop Z test,
I'm
two
being
stamp
really
Z
I'm
test,
not-
Z
I'm
interval.
I'm not seeing anything that says Z-test. All I see is. Give me a second.
Press stat and go to test.
Z interval, but then it says something about C level. What is C level? So many things.
What is A nova? Parentheses.
I think it's.
Another thing we talk about later on. I don't know.
Z-test.
I know for a fact it's interval.
I tried it. It didn't work. Yeah, I don't know.
And when you don't know and you're trying to figure an answer out and I'm not there with you, what are you going to do?
Google it.
Figure it out. Somebody be smart enough to figure it out. What is the answer? How do we make it go?
You get 0.001. 0.0001.
It should be 0.4 zeros and a 5.
That's what I got.
How? Okay.
Like heck of it rounds, I guess.
I can type letter E.
Well, clearly you gotta go to test somewhere in there.
Stop.
Oh no.
Good luck with that.
I don't like this game. I feel like I'm losing.
It's not Z-test.
You are. We're all losing. Suck it.
What?
Wait a minute, yes I can. Yes I can. I can totally do that. I think.
Go away.
Yeah, that's using stuff from. She's using stuff from. I bet she's using stuff from. just gonna delete all this so that if I don't do it, right, it also is 0.
Time out. Alex thinks he's figured it out.
Do it.
No, I think I'm.
You have the floor, Alex.
Hey, no fear.
Okay, wait, hold on. I
Carpe
forgot how I
diem.
did it.
Alex. Carpe diem.
I see no fear in your eyes. Do not hold back.
You're
I
worried
did that,
about-
and then test, and then I did Z test, and then I changed it to stat instead of data.
Because you don't have a data set, that would make perfect sense. Yes,
And then
if
I-
you won't.
And then I changed the mu thing to 389, and I changed the sigma, I think that is what it's called, 1, and x bar to 0, and then where it says greater than
What'd you choose for your N?
1,
So you ran one thing. Okay, cool. Next.
and then I changed the thing to greater than, and then I pressed calculate.
And it gave you.
Well, I think that the number that should be on the chart is like a bunch of 9s, and then like 4
So
nines.
1 minus that might give me the answer then?
I think so.
1 minus and
You said
answer.
it's-
Do 1 minus answer.
Is it
Hunter, do not steal our thunder. We earned this.
is it
No,
Wait.
she changed that.
is it 5.0141 times 10 to the negative 2 times 10 to the negative bit?
That would make sense.
That would make sense. There's a lot of zeros and a 5, yeah.
Yeah, mine rounded to
Cool.
Okay,
So how did you do it?
but we definitely
I
got that.
pressed the calculate button and then it showed me.
So basically you use all the steps he told you first?
Oh,
Yeah.
oh, way to run our
Okay.
screen.
Oh, so Alex, on your screen, you said you typed in, you went, okay, so Alex pressed stats, then he went to test, everyone was there with that. He pressed Z test. However, you and I would have left it on data. You can't leave it on data because that's wanting a specific list of data. We don't have a list to go from, so we've got to head over to stats. He decided for the mu to put 3.89. For the standard deviation, he put 1. For X bar, for the average, he put 0. Now, why he chose n equals 1, that's on him. I don't know. Would it change if we did n equals 30? Because that's how many samples we're taking. I don't know. Why did you choose greater than?
Because, like, on number 4, it says the Z score is greater than.
Okay, but then when we press calculate, my P is 0.99994 something something something. And you're saying you think it's 1 minus that.
Which it is.
So should we have picked less than?
Okay,
That's
maybe.
the opposite.
That's the opposite of what we were thinking.
No, it's like Steve Wright going all over again. So,
Oh, that did work too, didn't it?
so what's the answer? Oh, that's exactly what I got.
It's that 0.0005.
That's
0.0005 because if you move the 0 over 5 times,
Good job, Alex.
it's 0.0005. Now, Louise is right, and we're being a bit pretentious. And yes, did we need to know that the calculator could do the things? Yes. Do we now know to go to Z-test and put it on stats? Yes. But can we figure out the rest of it from there? Probably. We've got to type in the 1, we've got to type in the 0, we've got to type in that Z-score somewhere. However, was Louise right in that if we just realize by the pattern or by just life in itself that it's going to be so small it's basically 0 and we wrote something smart to that effect, that probably would be sufficient. But if it's a multiple choice question, we probably actually need to be exact and we want to calculate it with a calculator. Say words.
Oh, I didn't know if you wanted me to award Alex.
You can award Alex a point for figuring out
I
math.
think he gets 2 points for that.
had a calculator, how do you do it?
Very good.
All they used to use is the table. But, I mean, the calculator can do everything that's on the table and then some. So, really, all the problems you and I are doing, we could use the calculator for the entire time. I just like the table. The table's fast and easy to read. Does that make me lazy? Probably. You probably could do the same with the calculator. However, the calculator, and there probably is a way, I'm just not smart enough for it at the moment. Number 5, I think is way easier with a calculator. I mean, with a table, but it could be easier with a calculator if I was more calculator sufficient. Why is number 5 hard?
You have to find the upper or lower bound.
Yeah, so we're going to do 5 and 6, and then I'm going to give you your thingy. So let's see, 0, 0.49, 1.82. They're not asking us to find like above 0.49. Oh no, they want to know this exact region in between. What percentage is that exact region? And then you can't see what I'm doing. That would help. What percentage is this between 0.49 and 0.82?
So you back.
Yes, that would be the easiest. So we're going to break it into two parts for those of us who need to see colored pictures. So we're going to try to figure out above the 0.49 and then below the 1.82, and then where those regions overlap, that's going to be our answer. So we've got to find the 1.82. So looking at our table, 1.82 is what value? 1.82. You look at your Z table, 1.82.
Oh, wait.
1.82. You look at your Z table. Jackson wants points. I'm trying to give out points.
0.9656.
And your group can have a point. So 0.9656. So that's telling us 5.6, Miss Compton. So that's telling us the entire region below 1.82. That's why it's such a big number. Okay, but we're wanting to figure out the overlap. So we're going to subtract. Say words, Mackenzie. You're not Mackenzie. You're
No, like,
Good
I don't
Lord.
subtract
You're Olivia.
0.49. I'm getting really confused. Wait.
This is the first one where we've not just been finding all below or all above. This is the first one where we're trying to find an overlap region. So I found the giant one, the 1.82 region. So we pretended. So I found this giant one, right? And now I'm going to go and find,
Wait, so you found that one because it's less than
yes, I found this one,
less than 1.2.
so, which is the less than 1.82, which was this number.
You get that number by doing that chart thing?
Yes. And I got this number from my table. And now I actually want to find greater than 0.49. And when I subtract it, I'm going to end up having that middle region where they overlap before I got super colorful.
So wait a second. So on the chart, I think that's what the chart thinks. So if I'm going on the chart, what am I looking for? So it's going to be what number? I'm looking for
Well, I already found 1.82. Now I'm going to look for 0.49.
on the chart.
So I look on the chart. I've got 0.4. I need to find 0.49, which is 0.6879. So I've got 0.6879. But if we're looking back at what Miss Compton just drew, we were saying 0.6879. If we were going up below, would be 0.6879. But then you and I shade above. Isn't on our chart. Isn't it shading below? Don't we need the above? So we're going to do 1 minus 0.6879, which is what?
Yes.
Too much going on in the one picture. Let's
0.3121.
too much going on in the one
That
picture.
didn't help.
Too much going on in the one
Need some
picture.
whiteout.
I
Whiteout
need
wasn't
some
talking
whiteout in my life.
Really?
So we had P is less than 0.49, 0.49, and it's less than 1.82. We wanted to find on our curve 0's here, 0.49's here, 1.82's here. We were wanting to find the region in between where they're shaded. Yes. We're wanting to find in between where they're shaded.
Yeah.
So we find the 0.182, and I'm being a blonde. So we found the 0.982, which was all of this, right? And it was the number 0.9656 when we looked at our table. We looked at our table at 1.82, and it was that number. Yes? Then we looked at our table for where it was less than 0.49, and we found out it was, so for the pink region, we found out it was 0.6879. And now if I was being smart, Don't the pink and the purple overlap? But we want to know where they're not overlapping. So why don't I take my number, subtract off the overlap, and I'll have the real answer.
So you just subtracted the pink from the purple?
Yes, so basically, I think that picture does it better. We wanted to know the green, but you can't just directly use the table and find the green. So I found the whole purple, and I'm going to subtract off the pink. I found the purple, and I'm going to subtract off the pink, and it's going to give me the green. Does that help?
Yeah.
Okay, so the answer is,
0.312.
you can have your point.
I lied.
Number 5.
That's not 3121.
I lied.
Yeah, you need to do that better.
Subtract your point.
0.2777.
That's what I thought.
No.
That's what I thought. Yes, dear.
Why did minus 0.687 not from 1?
No, that was when Miss Compton was too much going on in my one picture. That's why I went to this one, and I have to relate it back to colors.
So you don't do that at all?
No, I found my purple, which was everything less than 1.82. I found my pink, which was everything less than 0.49. And then when I subtracted the difference, I ended up finding that green region. Because I subtracted off where the two overlap, so I could find just where it's just purple alone. Okay, and then there's only one left, and I swear it's easier than that one. So the worst are when it's a two-region one, because you end up having to actually think with your brain, which is sometimes a struggle. Trust me, even with me, it's a struggle. Struggle's real today. The last one is easier. They want greater than 0.97, but it's absolute value, so there's another point I need to consider, which is your group now point. So really, when it says I want greater than 0.97, yes, they're wanting to know the region over here, but they're also wanting to know the region over here because of those absolute value bars.
Could you find one of them and just double it?
That's exactly what we're going to do.
Cool.
So if you go to your table and find 0.97, it says, I'm going to beat you, haha,
0.834.
8340.
Yes, I mean,
But is that the answer we're going to write down?
no.
Why?
You need to double it. What?
I'm questioning my whole life right now. Don't make me question my whole life. Why is 0.834 not the answer? And for the love, why would you double it? Because that's going to be way over 100%. That makes no sense when it's two tiny, tiny
Divide
ends.
it by two.
You just
I don't know what I'm looking at.
You have to
Alright,
subtract-
let's call it
I
a
guess.
day.
I took a guess.
Are you looking at the other charts? You guys subtracting one?
I thought the probability table on my paper was a region shaded to the left, yes. But I'm wanting to know the region to the right.
So you guys subtract one.
So don't I have to do 1 minus whatever? So aren't I supposed to do 1 minus 0 point numbers you said?
834.
What you said?
1.166.
And you get 0.166, and then yes, you can multiply that times 2,
Okay, wait.
1.332.
Dang.
0.332. But if Sally likes that negative table, she could have just gone to it to begin with, looked at negative 0.97, it was 0.1660 to begin with, and if she doubled it, she would have also gotten 0.332.
Okay, but with the absolute value bars question, it makes the negative table like really easy to use.
Yes.
I like that.
Yes. Okay, so then for those of us who, because no offense, but if Louise is questioning, if Louise is blonde, then we need to summarize our whole life. So let's go back over it again. So we wanted to know this region over here, but that's shaded to the right. Our table tells us the region shaded to the left. That's why we had an issue. So when he told me 0.97, when he told me 0.8078, or whatever number it was he told me, we had to do 1 minus that because we don't want that we want the region to the right. We don't want that left region. So he was supposed to do 1 minus and get 0.166. And then yes, he's right. You could double it because the two tails should match. So So that's one way you could have done it. Way number 2 is you could have used your calculator. And then way number 3, which me and Jackson probably would have done, what if we just looked, since if we had ignored this part, the negative 0.97 actually is shaded to the left. So I could have used my handy dandy table with the negative, gone to 0.97, oh look, 0.1660, and then just doubled that instead. So technically Jackson and I are doing one less step than Louise. But heck, it's a test, so wouldn't you do both to check yourself?
Nope.
One would pray. And Louise realized he was wrong when he realized 0.83 something doubled was going to be over 100%, and for the love, that's never going to happen in life.
I trust graphs.
I trust no one.
I think you should, I'm sorry.
I trust no one. Maybe.
Trust
I
no
don't
one, not
care.
yourself.
I don't know. I'm literally